Imagine you woke up one day and decide to run some C++ code inside your KMP application. Maybe you want to implement encryption or do some low-level audio or video processing. It's up to you. Or maybe you already have an existing C++ library you just want to reuse. Unfortunately, Kotlin multi-platform doesn't provide a unified solution for calling C++ code directly, so we need to integrate it separately for each platform. On iOS, this is actually quite straightforward. Object-C can call C++ code, so the bridge is already there. But what about Android? Android uses something called JNI, Java Native Interface, and this is exactly what we are going to use. In this video, we will focus on Android integration. In the next one, I will show how the same idea works on iOS. But first, let's take a look at the architecture. We remember that there is a compose submodule and it contains common code. In this tutorial, I will show a project in which both UI and business logic is shared, and I will organize it the way how actually it works in production project. And to integrate native code, we will utilize expect actual mechanism. The expect class will be located in the common code, and actual implementation will be in specific platform modules, calling actual native library code. Okay, let's go to Android Studio. Let's jump straight to the code. So for demonstration purposes, I have created a very small and simple application. It's a C++ calculator which adds one number to another one and shows you a result. And let me show you some changes I have made. So you can see that this project is already separated into different folders. And this is actually how production-ready project looking like. So we have a section for data, and for platform, we expect an actual, but it's up to you. Presentation 1 and UI. Let's open UI. And here we have a pretty straightforward composable, and there are two outline text fields responsible for first and second number, and there is also view model responsible for business logic and repository inside it. So the most important logic is located here in button click, and if you go here, you'll see that it just takes first and second number, makes some very basic validation, and sends results to repository and calculates the sum. So repository is super simple, it just adds one number to another one. What we're gonna do it we are going to make it more complex, and first we will create expect an actual object for native calculator, and in Android actual implementation we will be calling C++ code via JNI bridge. So let's do it. Here in common main I will create a new object. I will call it something like a native calculator, for example, and I will change it here. So it is now expect object, and it will contain one function only, calculate sum, and this is a Kotlin code, so syntax is pretty straightforward. Okay, so you can see it just shows us red, and if we click on it, it suggests us to create missed actuals, and let's create one for Android first. And for now, we will return just a sum of it, number 1, number 2. And let's create one for iOS. The same here, number 1 plus number 2. So iOS integration we will not cover in this video, it will be the next one. Let's go back to implementation here for Android, and what we're gonna do here, we will call GNI bridge from here, but to call it we need to create it. So for demonstration purposes I suggest to just create a GNI module here. Why? Because GNI bridge needs some files already generated, and we will refactor it later on when we will combine both Android and iOS integration, like GNI for Android, Interop for iOS. But for now, I just want them to be generated for us and make a simple explanation here. Like, you can change the name as you want or leave it like this, it doesn't matter actually, and wait for a while. So it says us, okay, please migrate. Actually, we don't need it. It's enough to do it like this. Okay, and try again. While it is generating, let me show you what is here. It's quite important part here, section CMake. So we know what a CMake is. Application which is actually built in C++ files. So there are two important things: is CMake list. Let's go to it. It's a text file, and it has some information about how to build this library. So first of all, it declares the name of it, and afterwards you can refer it using CMake project name, like here. Add library. Here you need to list all the C++ source files. For example, if you add some of them, please don't forget to add it here. And here, if you're using any other third-party libraries or I know Android system libraries, please also use it. Mention it here, otherwise it will not build your code correctly. Also, don't forget to add to ProGuard rules exception for your native code, otherwise it will not be called. It will not be found because it will be obfuscated. All the rest is kind of the same. So what is next? We have a native lib CPP, but if you go to Java, we see this file. So there is a class, it has an external fun, but if you call here, it goes to this CPP file and actual implementation in C++. So this is exactly GNI bridge, so Java native interface. And we will do exactly the same. So let me add external fun. Let's call it calculate sum. Also number 1, number 2, integer, and it's red. Let me click on it and suggest to create a GNI implementation. Okay, so actually you see that this function has more parameters than our original code. And what is it? So here C++ developers definitely know it. It's an environment, reference to environment. You can take some variables from here. This is a current JObject and our two parameters, number 1, number 2. And what we're gonna do here is just to return some of them. Number 1 plus number 2, that's it. So we can also add some C++ code here, like, you know, include and move headers here, etc., etc. But if you do it, please don't forget to also add it to CMake list, so nothing will be forgotten and everything will be built correctly. Okay, great. Now, what we're gonna do, we need to include this module to our Android main. And how to do it? We need to open a build, Gradle, Android main, okay, implementation, projects.nativelib. Okay, fine. I hope everything is okay. Let's go here, and now what we can do, let's do actual here. Fine. So we can actually see our GNI module code from here. Let's do native lib Oh, it's actually here. Native lib. Great. And now we can call it calculate sum number 1 and number 2. So we're just going exactly to this function, and this function is going to C++ code. This is exactly what we want to do. Okay, so what else? We can actually probably run it. And no, we cannot. Why? Because we need to call this native calculator from the repository. And let's do it. So native calculator dot calculate sum number 1, number 2. Great. Okay. So all parts are already connected, and actually we can run our code and see if everything works fine. Great. Let's do. Okay, everything works. So in this very simple example, we have covered all the connections, and the next one will be about iOS integration. I hope it will be useful. And now it's time to talk about very important things. We will talk about what can go wrong. Okay, great. Now we have working code, and it's time to cover some possible production pitfalls. How to find them, how to resolve them. Let's get started. And the first one I wanted to mention is about different architectures and SO files. We need to remember that Android supports a huge variety of different devices and different architectures. Some of them are obsolete, some of them are actually in use. And here we need to mention that there are two ways of distributing your application. The first one is via Google Play. In this case, an AB file will be generated. And the second one is about outside of Google Play via APK file. Maybe you need to publish it on a specific website, so your users will be able to download it. If you choose APK, you might find out that if you include all the architectures to your build, it will significantly increase in size. To fix that, there are two ways. First one is to reduce ABIs using ABI filters, but this might crash on devices not mentioned in your filter, or using the mechanism of APK splits. In this case, different APK files will be generated for each architecture. Or if you are using a modern AAB file format, and it splits automatically, so you don't need to worry about it. It just won't show your application to unsupported architectures. The second pitfall I wanted to mention is about unsatisfied link error in runtime. So there are several scenarios I wanted to cover in this case. The first one, when wrong library name is used. And keep in mind that you just need to load the library name without any extensions. The second scenario, when library doesn't exist in APK or AAB file. This might happen if your source sets or JNLib paths are incorrect. So to check it, just unzip and check folder if your library exists there. Or what might happen, that initialization order is wrong. So it might happen when you are trying to call your library before it is initialized. So make sure you're loading library as early as possible to guarantee that it's loaded before any usage. And the third one is about thread safety. So your C++ code doesn't know about Kotlin coroutines at all. If you call native code from different coroutines simultaneously, it might lead to race conditions. And there are two possible solutions coming to my mind. The first one is adding synchronized annotation, and another one, have a separate dispatcher for your native code. Choose whatever is appropriate for your project. And the fourth one is about memory leaks. So we remember it's a C++, we have different references, we have weak ones and global ones. So if you are using a global reference, you need to keep in mind that you need to call delete global ref method in it. It's just a good practice to set it to null PTR. I just wanted to mention it, it's not obligatory. So the next one, quite common actually, that debug build works, but release doesn't. So first thing usually we think about is about obfuscator, and please check that your keep rules have it, and be sure that whatever you're adding it there too. And the last but not least I wanted to mention is about CI/CD. So for example, your application compiles locally, everything works fine, but it fails on CI. So the first thing I would think about is that there are different versions of NDK on your local machine in CI agent. And the solution is to explicitly set up NDK version here. If you're using Dependabot, please make sure that you are keeping an eye on it, because it doesn't update automatically NDK version. I guess something about Cocoa Pods too, but we will cover it maybe later on. That's it. This is all I wanted to cover, and I hope you enjoyed it, and happy KMPing!